Yeah, to follow on, previous video I did was about a dimensional sort of matrix, and just like how binomial theorem, and anyway, just give you an example. In this one I'm going to be talking about first and second dimension, and how harmonic numbers, Tetrractys, Pythagorean numbers, triangular numbers, how these patterns work together. But okay, so just we'll go over previous video quickly. So if we have like the first dimension, so 1, 2, 3, 4. Okay, so we imagine like a train line. The first dimension's, it's a straight line. You can move back and forth, and pretty much that's it. But when you bring in the second dimension, now we can think of more like a cartoon character. He's on a piece of paper. He can't move towards you or away from you, but he can move up and down and side to side. He has 2 dimensions of movement. So, now go like previous episode, like now, so this next number would be 2 squared, and we can just, if you know that we add 1 plus 2 plus 1 equals 4, which is 2 squared, and the same thing happens again. 4 plus 2 plus 3 equals 9, and that equals 3 squared, and the pattern would, well, it does continue on, so, and that's 16. So what we're seeing is how first dimension and second dimension, in that this would be 2 squared, 3 squared, 4 squared, etc., going on for infinity. And so just a little example of how first and second dimension numbers work together, and people who are familiar with the harmonic numbers will also start to see some of the beginnings of it there anyway. Another thing is we have a symbol people might have seen is triangle. It's all in screen with 4 dots. This is called the Tetrractys. Yep. Sacred symbol to Pythagorean sets. This is, they swore an oath upon this, but if we count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so we can, you say there's a number attached to it, and that's 10. And quickly, if we go back up here, first dimension, we can think of the first dimensional numbers here, 1, 2, 3, and 4. We can connect them to here. So 1, and we have 2 dots on the second row, 3 dots on the third row, 4 dots. And so 1 plus 2 plus 3 plus 4 equals 10. So that's now if we draw it, and so these numbers was how 1 dimension and 2 dimensions work together. So that now we start to see if we, another way of visualizing that is through the Tetrractys and triangular, what's called triangular numbers. So if we have so we have triangular numbers, and just like the Tetrractys over here, we have 1 instead of 2 dots, so we have 1, 2, 3. So we're using numbers instead, and then the next row is 4, 5, and 6. The next row would be 7, 8, 9, 10, but I'm going to stop at these this triangle here. So and the importance of the number 6. So the number 6, why is it important? Well, it's a perfect number in that 1 plus 2 plus 3 equals 6, a triangular number, but also 1 times 2 times 3 equals 6. This is like a super rare of the perfect numbers that come back to the triangular. So 6, and then it would be 7, 8, 9, and 10. So just like our 10 dots on the Tetrractys, we've just drawn them out with numbers. And so now I'll quickly look at them. So we have the first row is 1, the second row is 3, the third row is 6, and the fourth row is 10. Now I know if I add 1 plus 3, I'll get 4. Okay, if I add 3 plus 6, I'll get 9. If I add 6 plus 10, I get 16, which is 2 squared, 3 squared, and 4 squared. So the adding any two neighbouring numbers will bring the square of the larger. So the fourth row, if I add the third and the fourth row together, 6 plus 10 equals 16, which is 4 squared. Fourth row, 4 squared. Now, just a quick overview. So it's basically 1 and 2 dimensions into relationships, how they relate to each other, Tetrractys, perfect numbers, harmonic numbers, and how they sort of have there's this, starting to see like how squares connect back to them. And another example of that would be the Fibonacci. So we have 1 plus 1 is 2, 1 plus 2 is 3, 5, 8, 13. Now when we draw the Fibonacci spiral, you create a bunch of little squares and rectangles along the way. So these are the one-dimensional area, the one dimension, like describing the edge length of each rectangle as it builds within the spiral. So that's the first dimension, but the squares themselves and rectangles have a relationship in regards to area. So we can work out the area, is what I'm trying to say in short, of each rectangle, and that's so 2 times 1 is 2, 6, 15, 40, and 104. So that's this would be the area of each square, so the second dimension now. But now let's do, what's the difference between this number? So 2 minus 1 is 1. The difference between these two is 3. 4. Well, I think 6 minus 2 is 4. 15 minus 6 is 9. 40 minus 15 is 25. And 104 minus 40 is 64. And, well, that's 2 squared, 3 squared, 5 squared, 8 squared. 2 squared, 3 squared, 5 squared, 8 squared. So yeah, I posted a bit about harmonic numbers and measurements, but this is sort of just a quick touch on how first and second dimensions connect together. It's all these sequences sort of have a same set of relationships going on. So anyway, hope you enjoyed.